So this one is exercise related to atomic physics. The first 7 questions we did from this exercise. So we have question 8. In question 8, a radioactive source is placed 20 millimeter from a radiation detector. So you can see a detector is there, a source 20 millimeter, and a lead. What is the purpose of this lead? That is to collimate the beam, like to focus. Because what will happen if this lead was not there? It's not like there's an opening in the lead. So what is the reason for having an opening in the lead? So if this is a radioactive source, if there was no lead placed, then how because radiation, this part, the holder is made up of lead, but radiation will move in all the direction. So to collimate or to focus the radiation from the source, this lead box is used or lead line is used. Only the radiation which is passing through the gap will able to pass, and rest of these radiation won't be able to pass. That's why. So you can say it is used to collimate the beam of radiation, or so that the radiation can come out in a beam. That's the purpose of this lead. They did not ask for it, but as an information, you should know that why this lead is placed. Because this is not like completely blocking the radiation from the source, as there is an opening there. So some of the radiation, you just write it to collimate the beam. Or collimate the radiation from the source. Okay, the next one, we have to identify in the question, initial count rates were 150 counts were there. So initially we receive 150 counts from this. Then a sheet of a paper is placed and between the source and a detector, and the count rates have fallen to 60. So initially when the count rate were 150, but now it has fallen to 60. Is there an alpha present in this? Yes or no? We place
Yes.
a, yeah, so there should be an alpha, or alpha is present there. How we identify that there is alpha? Because the radiation fall to like reduce the number, which shows that there is an alpha. Then when a magnetic field is applied, because alpha cannot penetrate through the paper, that's why, with a paper still in place, like there is a paper and the magnetic field is set up perpendicular to the direction, the count rate fall to 20, a very low, like it fall to background radiation. So what this give an idea? Look what we did first. Initially we place a paper, like we were receiving 150 radiation from the source plus the background. Then we place a paper in front of this, and we found that the counts have decreased to 60. Then we apply the magnetic field in this region. So in this region, when we apply still some radiations are there, because still we are receiving some. So initially 150, but most of them are stopped by the paper. Then when we apply, we are getting 60 count. But when we apply the magnetic field, as a result, the detector read now 20, means the detector is recording background. So means detector is not able to detect the radiation from the source. So what we can say now, we can say there is also a beta was also there. Because if beta was not there, then the count should not change. When we apply, because when we apply the magnetic field, the radiation, if it's a beta radiation or alpha radiation, magnetic field apply perpendicular means like cross is there, cross or dot. If it is cross or dot, it means the magnetic field is perpendicular to the direction of the motion of particle. So the particle will move either up or down depending on the nature of the particle. So what we can say, when we place a paper, we can say there was alpha. But when we apply magnetic field and the count further decreases, it shows that there is also beta, because alpha and beta can be deflected by the magnetic field. Gamma cannot be deflected. If there was a gamma and we place, or when we apply the magnetic, we place a paper and we apply a magnetic field either in or out. So, and say without paper it was 150, with paper it was 60. And when we apply the magnetic field, if it remains 60, it means there was no beta. Because, but now what happened, as the radiation have fallen to a smaller value, it shows that there was a beta. That's why applying a magnetic field deflect the beta. And the count rates, the next one, the count rates have not been corrected for background. So means background measured was 20. That's radiation not corrected for background means we did not subtract the background radiation, and the background radiation was 20. So what give an idea about this? State the evidence that each type of radiation is present or absent from a radiation emitted from the source. So alpha, we will say it was initially present. And what is the evidence? Because the paper blocked the alpha, which reduce the counts. Then beta is present because it deflected by the magnetic field. And it also reduced the counts when the magnetic field is applied. But gamma not present. And what is the evidence? Gamma is not present because the radiation with paper and a magnetic field are same as the background. Like if it was not, like example, if it was not 20, say 30 was there, so it means there was some gamma. But because the radiation with paper and the radiations which we record with paper and magnetic field same as background. So this give an idea that there was no gamma. So in part B, we have to determine the original count rate, how much the original count rate of 150 is due to each type of radiation. So alpha, originally it was 50, but when we place a paper, it has turned to 60. So 150 minus 60, it will be 90. Then when we apply a magnetic field, before we apply the magnetic field and paper was there, it was 60. But when we apply the magnetic field, it has turned into 20. So how many radiations are there due to beta? That is 60 minus 20. And for gamma, there will be no radiation from a gamma as the source is not emitting out gamma.